This lecture is going to be on how to interpret blood gas data. A primary acid-base disturbance is when there's a disease in a system, either metabolic or respiratory, that ultimately results in an acidosis or an alkalosis. A compensatory acid-base process is when a system, again either metabolic or respiratory, attempts to correct the primary acid-base disturbance. For example, if there's a primary respiratory acidosis, then the metabolic system attempts to correct the blood pH by creating a metabolic alkalosis. A simple acid-base disorder when there is only one primary acid-base disturbance. A mixed acid-base disorder is when there is more than one primary acid-base disturbance. Your notes also define combined and complex acid-base disorders, but you don't have to worry about those terms for this course. There are 5 steps to blood gas interpretation. First, you want to classify the pH, the metabolic process, and the respiratory process using blood gas results. Then you want to identify the primary process by seeing which process is going in the same direction as the pH. Lastly, you want to identify any compensatory process, and the compensatory process will be going in the opposite direction of the pH. In this first example, the decreased pH indicates an acidemia. The increased bicarbonate indicates a metabolic alkalosis. The increased PCO2 indicates a respiratory acidosis. The primary process is the respiratory process, and that's because an acidosis is a process that causes an acidemia. So there's a primary disease within the respiratory system that is causing decreased pulmonary gas exchange and therefore hypoventilation. The metabolic process is compensatory, and I'll abbreviate that with a C, and that's because an alkalosis would lead to a pH change in the opposite direction of an acidemia. So the metabolic system is attempting to correct the pH that has been altered by the primary respiratory disturbance. Since there is one primary acid-base disturbance, this is a simple acid-base disorder. In this example, the decreased pH indicates an acidemia. The normal bicarbonate concentration indicates the absence of a metabolic process. The increased PCO2 indicates a respiratory acidosis. The primary process is the respiratory acidosis because the acid in the acidosis matches the acid in the acidemia. Therefore, the respiratory system is diseased and is causing the change in the pH. There is no metabolic compensation, so there's no compensation, and that's because the bicarbonate is within normal limits. So remember, the kidneys take 3 to 4 days to compensate for a change in pH, so there probably just hasn't been enough time for the bicarbonate to change. Since there's one primary acid-base disorder, this is also a simple acid-base disorder. In this last example, the decreased pH indicates an acidemia. The decreased bicarbonate indicates a metabolic acidosis, and the increased PCO2 indicates a respiratory acidosis. Both the acid in the respiratory process and the acid in the metabolic process match the acid in the acidemia. So both processes are primary. Therefore, there are diseases in both systems that are contributing to the acidic blood pH. There's no compensatory process. Since there are two primary acid-base disorders, this is a mixed acid-base disturbance.